This video introduces the concept of a definite integral. So let's review what an indefinite integral was, which is what was introduced in the previous video. So an indefinite integral, if we think of our example of f of x is equal to 4, then the integral f of x dx was going to be equal to 4x. And this is what's called an indefinite integral. Now, what about a definite integral? So let's think back to that first video, and using the f of x equal to 4 example. So we're still going to have f of x is equal to 4. Now, suppose I'm interested in finding a piece of the area. So we did this in the previous video, but this time I'm going to write the integral a little bit differently. So I'm going to write f of x dx, but this time I'm interested in this area from 0 to 3, and I could just write my 4 dx like so. Now if I actually integrate this thing, if I integrate it, I'm going to change my sign from an integral sign, a definite integral sign, which is that thing there, and I'm going to just put a straight line with 0 at the bottom, 3 at the top. And when I write that straight line, it means that I've integrated. So I've integrated this function. And I'm going to write, in this case, 4x. And this thing is going to be equal to the distance from 0 to 3 using this integral. And so I would write it as 4. Wherever there's a x, I'm going to put a 3. And then I'm going to have a minus. So I'm looking at the area between 3 and 0. I put a minus, got a 4, right? That's the function itself, but this time x is going to be 0. And what do I get when I evaluate this the integral of f of x from 0 to 3? I'm going to get the answer 12, which if you think back to the first video, that was the area under the curve when x was equal to 3 and f of x was equal to 4. And these numbers here are known as the limits of integration. Now, definite integrals are a great way to measure the area underneath a curve. So if I go back to our very simple example where we have f of x is equal to 4, if I wanted to know this whole area down here, then all I have to do is integrate with respect to f of x, and then I want to set the limits of integration to 3 up here and 0 down there. Let's formalize our definition of the definite integral. So let big F of x be the antiderivative of f of x. And I'm going to write the integral from b to a. Those are my limits of the integral for f of x dx. And this is going to be equal to, maybe I'll just put that out over there. This is going to be equal to the integrand big F of x. So I integrate first, and then I want to find the area underneath this function, and that's going to be big F evaluated at A minus big F evaluated at B. And we can put any number we want in for A and B. So B could be equal to -2 and A could be equal to 5. It can take on any value. In this course, we're not going to really talk about infinity, but it could be, one of them could be infinity or negative infinity for that matter. But just imagine that A or B are just some number. Right? A and B are some constant real number. And the last thing I'll add is this symbol down here. This tells us that we are integrating over the interval B to A. So we're integrating over the interval B to A. It's generally the case that when you have a definite integral, your answer is going to be a number or things representing a number. And when you're integrating an indefinite integral, you're going to get an algebraic expression. It's not always the case, but generally that's what you're going to find. So here we have our indefinite. So we have an indefinite integral over here, and we have a definite integral over here. And we'll do the indefinite integral first. So I've got a function x, and I want to integrate it with respect to x. Well, that's going to be equal to x squared over 2. Right, we learned that in the last video, and we're done. We don't need to go any further. Now with the definite integral, we've got an intermediate step, so I'm going to draw my interval. In this case, we're going from A to B, so it's a little bit different than the previous slide, but otherwise it's the same. And then I'm going to integrate x, so I also get x squared over 2, integrating with respect to x. And now I will, maybe I'll go down here, and then I'm going to now evaluate this thing on the interval A to B. So I'm going to get b squared over 2 minus, always the minus, a squared over 2. And if I want to then I can just go ahead and simplify this thing. I can factor out a 2, and then I've got b minus a, b plus a. If I wanted to, if I've just got the b squared minus the a squared, I could factor it out since it's a difference of squares. And if I gave you values, if I said, b was equal to 2 and a was equal to 1, then this thing is going to be equal to, 3 over 2? And so there's the difference between the indefinite integral and the definite integral. Definite integrals, this is subject of our next topic. This is a, among other things, a way to find an area beneath the curve. And so let's talk about that next.